Right, so like we say, you know what I'm saying? So all the other numbers gonna work domain of function of f, all real number. When you say real number means any real number, except this x should not be equal to 3 over 2, because when it's equal to 3 over 2, it's gonna cause a problem there. You know what I'm saying? So, and that's how you solve. You know what I'm saying? But other stuff they say, oh, x, no, it's not problem, because when x equals to 0, so the option, this should be the option. This is your answer here. If the right something else, no, then it's not the answer. So this is your answer. And you can even prove this if you want to prove. Let's take, but that's the answer, right? You're done already. Let's take this value, plug in there. Look, it's gonna be 3 means f of, what is the x? Excuse me. What is the x? X, we say it should not be equal to 3 over 2. Let's put 3 over 2 now. Means you're gonna say function our x is gonna be 3 over 2. Let's assume 3 over 2, because we just say it should not be equal to 3 over 2. So we're gonna plug in here. So we have 3. What is the x? 3 over 2, shows me, and then over, and then we have a 2 times, what is the x? 3 over 2, because it should not be equal to 3. But let's take, if it's equal to 3 over 2, what's gonna happen? Minus 3. Now let's go. 2 and 2 cancel. So we're gonna have here 9 over 2 to the numerator. 9 over 2 over, this is going to be 2 and 2 cancel, so we're going to left you 3. 3 times 1, 3 over 1 equal to 3 minus 3. 3 minus 3 equal to 0. So we're going to have a 9 over 2 divided by 0, which is undefined. You know what I'm saying? So I hope everybody understand. If you have any question, please let me know. I'm going to make a special lesson on this topic here, right? Okay, so now, so the option 1 is not true. You know why it's not true? Excuse me. Let's go to the equation. The option 1 is not true. You know why it's not true? Let's go to the option here. So it's not true because if you come here to say option 1a, look, they say x is not equal to 3 and also x should not be equal to 0. Nah. The first part is true. Domain of x are all real number, and that x should not be equal to 3 over 2. But that x not equal to 0, no, hell no. So that x is not equal to 0, it messes up everything, so it's not true. Now we go for B. So for B, the one domain of G. Now we go for G. So I'm going to have to explain the same thing, explain the similar things like how I did here, and there we go. So now you come to the situation whereby, excuse me, just a second, I appreciate, thank you. So now you come in a situation whereby you have, let's say, 3 over square root of any number. Let's say x. So see, this is, this is not like the first one. This one, the root of a function is at the denominator. So if the root of function is at the denominator, you know what happened? Look, first of all, no, this should not be equal to 0. All of it should not be equal to 0. Because if equal to 0, it's going to be a problem. All of it. So what does that mean? Means square root of x should not be equal to 0. And then what happened? And then how I'm going to get x, and then square, and then how I'm going to say what? Square. So this and this cancel. So x equal to is not equal to 0. So x should not be equal to 0. That's the first thing. You know what I'm saying? You know why it should not be equal to 0? Because if 3, we can test, and they say 0. So what you're going to get here, you're going to get 3 over 0, because square root of 0 equals to 0. And then what happened? This is going to be undefined because it does not exist. We say, if somebody come and take out all your tire, cut your leg, you know yourself, how are you going to go to write exam? Or if you're going to say you can't go write exam. Or somebody come and break you, I don't know, you know what I'm saying, take all the tire for a car, how are you going to drive? You can't. Or if we live in here, so I'm saying, we creature, and then let's say all of a sudden there's no ground, how are we going to exist? We can't. So it's going to be undefined if all denominator equals 0. But the main one, when the root is at the denominator, you know what I'm saying, when the root at the denominator, you know, look, you have a 3 over square root of x. This number here, it must be greater than 0. Whatever is in the root. Okay, I'll say it again. It's very important. If this stuff, when the root is at the denominator, like 5 over x minus 1, all this stuff which is in the root has to be greater than 0 for this stuff to exist. I mean, all this stuff, you see this one? It must be greater than 0. Guys, look, man. I mean, try to understand, memorize my concept, what I'm saying. This is very important. So if you have a root at the denominator, see this root here at the denominator, take all the stuff which is in the root, it must be inside the root, it must be greater than 0. It's very important this. Okay, so for that case, for your function to be defined, so if this is, let's say, I'm trying to bundle of x, I'm trying to bundle academy, I'm trying to bundle academy equals minus x. So I'm gonna say for this function to exist or to be exist or to be defined, it means everything which in the root, which is x minus 1, must be greater than 0. And they check over x greater than 1. So you're gonna say x must be all element of real number whereby x also must be greater than 1 for the function to be defined. Done. Easy like that. So just remember, this is what you have to remember. If you have a function, see this is like a function here, and then your denominator has a root, take everything in the root, say is greater than 0. So what that means, let me so this is a final answer, you've done already. Let me explain to you what that means. Look, excuse me. So we say, let's start with this one. So let's start with this one first. G of x, and then we come for that question. G of x equal to, let's say, 5, we say 3, right, over square root of x. And what happened here? This, excuse me, square root of x, man, is sliding my power, square root of x. So we say, whenever denominator, root is of denominator is at the root, square root to any root is at the denominator, and they say this must be greater than 0. What is inside the root? So we're going to say x greater than 0 for this case, because that's inside the root. So x must be greater than 0. Okay, let's test other number. Let's test first if it's true. For example, if it's going to be defined for sure, let's go. So we have a 3 square root of, okay, let's take a number greater than 0. 0 is going to work because it's going to be 3 over square root of greater than 0. Okay, let's say 1 because 1 is greater than 0. Does it work? Yes, because if you take the square root of 1, you're going to get 1. So my answer is going to be 3 over 1. Let's say any number greater than 0. Let's say 4 is going to work because it's going to be square root of 4. Square root of 4 equal to 2. And yes, it's possible. So any number is greater than 0. What happened? How if it's equal to 0? Because you say it has to be greater than 0. Okay, if it's equal to 0, it's not going to work because look, you see what I'm saying, which contradict our answer there. We say it must be greater than 0 for this case, so it's okay. Let's say equal to 0 exactly, which is not true, means a contradict of what I say. So it's going to be 3 over square root of 0. And then what happens? It's going to be 3 over 0. See, this is undefined, which is not going to work. You know what I'm saying? Okay, let's take a number which is less than 0. Look, because say it must be greater than 0. Let's say negative 1, which is less than 0. So we're going to say, okay, so 3 square root of negative 1 or negative 4. So what happened? It's not going to work because you cannot square root negative number. So it's undefined. Oh, so it's true that whenever you have a root at the denominator, take the whole denominator greater than 0. Let's go and test the previous one again. So let me check out the previous one again. So we say this one again. So it's okay. We say you take whole denominator greater than 0. Only that's a tip. Don't worry about the take take if you have a root, but remember root at the denominator. Let me write here root so that you're not gonna forget. Root, when you have a root, any type of root at the denominator. And let's say find domain and range. Let's say find domain. So what you do, take what is inside the root. So for this case, you take what is inside the root, which is x minus 1 is greater than 0, and then we take over, so x is greater than 1. So let's test if it's true or it's not true. We say x must be greater than 1. For example, let's say 3. So it's going to be 5. Okay, square root of what is x? We say it's greater than 1, like 3. 3 minus 1. Okay, so say 5 over square root of 2, which is going to work because square root of 2 is going to get a number and then can put in the calculator, get the value. Okay, 5. Okay, any number which is greater than 1, let's say 5. So it's going to be 5 minus 1 equal to 4. Square root of 4 equal to 5. Square root of 4 equal to 2. Yes, it's going to work. So any number you see when it's greater than 1 for this case is going to work. But this is a procedure, right? Don't skip this procedure. If you want to do straight away, it's easy to make mistake because you're going to be guessing. Let me take 2. Let me take 5. Is 5 work? And now you don't like you guessing. You know what I'm saying? That's why you have to use this strategy. Work that fantastic. So now it's okay. So now let's take a number which is less or equal to 1 because they say it has to be greater than 1. What about equal to 1? Which you know is not going to work, but we want to see. Okay. So this is going to be what? It's going to be 5, and then it's going to be 1 minus 1 square root. And then what happened is it's going to be 5 over 0, and this is undefined, so it's not true. You know what I'm saying? Okay, let's say 0. So 0 is going to be 5 square root of 0 minus 1 is negative 1. Square root of negative 1 is undefined. Oh, it's true. So we see that's true. So for that case now, excuse me, our answer for the question Now we go back to our question because that's not was not part of the question. Shows me the answer to the question. Now this is a question right here. So answer to the question, we're gonna take all denominator of x, which is this one, and you have to say greater than 0. So we say x minus 2 must be greater than 0 for the function, because there's a root of the denominator. So we say x must be greater than 2, and they say x are element of real number. You can say put your curly bracket, and they say domain of g equal to. Done already. That's all. So we go to the option. You see the option? Yeah, the option is no, the option is not true because this option has x is greater or equal to 2, which is not true. It has to be greater according to the trick I've given you. So it has to be greater. So that option is not true. I can even prove to you. Then they say equal. Take equal, for example. Put here. It's going to be 2 square root. 2 minus 2, 0. So 2 is going to be 2 over square root of 0, which is going to be 2 square root of 0 equal to 0, which is undefined. You get what I'm saying? So it's not true, the answers. Now we go for the last one. Okay, so for the last one is easy, man. You know what I'm saying? They give you h of x, and they say x minus 2, and they got x minus 3, and they got x minus 3, x minus 3. So you know what? This type of question phase, don't start to say denominator, it should not be equal to 0. This one is straight away because this and this cancel phase. So if you do that strategy of denominator equal to, it should not be equal to 0, and then you're not going to make this one. Because you can simplify here, this and this cancel. So all the function become x minus 2. So h of x equal to x minus 2. So not all the function have got that tricky. This one is just a linear equation. So linear equation, all real numbers. So say domain of h, x are element of real number. That's all. So all the number weights. Or sometimes other people they say domain of h equal to x. And you go negative infinity because that's a real number, and then infinity always exclude. You can write like that. They say x exclude what? Positive infinity. This is the same thing. These are the same thing. So if somebody write like this, and then when you write infinity, never include here, right? Never, right? The way how we write here, you say only 1 because infinity you don't know where you're gonna stop, so you exclude. So the phase 6 question number 6 is done already. So we go to question number 7. So now let's go to the option. You see, option C is true. So question 6 only C is true. Question 6 only C is true. Question 6 only C is true. So question 6, I'll go only C is true. So now we go to the option. Okay, so if you go to the option here, excuse me, domain of h. I think let's see if excuse me, sorry. So now, all right. So there's something I think very important also. Real number, but I think there's something here I want to clear out, man. I say it, but I think it'll make sense more. You also have to include this one, even though I say no, you don't have to use that trick, but you're gonna have to use that trick. You know why? Because it's at the denominator. Why we should not use the trick? It means I have to reconsider both of these, and the one has simplified, even though the same thing. So for this one, it's gonna be all real number. But for here, it has to be all real number, but denominator should not be equal to 0. So denominator should not be equal to 3. So you take these both 2 together. So you say all x are real number, but except this x should not be equal to positive 3. So this one has to be involved also. You see what I'm saying? If you don't involve, you're going to be in trouble. You're going to be in trouble. So make sure you involve also. You know what I'm saying? So x are all real number, but this x should not be equal to positive 3 because there's a denominator. So you simplify and then you consider this one and this one also. So you have to do them together. So for that case now, all those options, none of them is true. Excuse me. So now we go here. So they say all real number. It is true, but there's something missing there. It has to be also x is not equal to positive 3. So I'll go for none of them. Option 5. So question 6, option 5. So question 6, option 5. Question 6, option 5. Question 6, option 5. So this is going to be option 5. None of them. None of them. Thank you so much. So now we go to question 5. Now we go to question 7, right? All right, let's go question 7. Alright guys, so let's go to the question 7. So let's say that's a question 7 right there. Which of the following statement is or are true? The first one, f of 0 equal to 0, f of 6 equal to plus or minus 1, and the g of x equal to root of h of x equal to 2. So just like I say, man, this equation here, right, it depends on they say equation. Look here, they say question 6 and 7 based on the following following definitions. So we're gonna use this function here given and solve the question 7. So let's go. Excuse me. So they say f of 0. So we know f of x. So we go f of x. Okay. So f of 0. Excuse me. So we got our function given here. Those are function there. We have f of x. So we say f of x face given f of x equal to 3x over 2x minus 3. So the one f of 0. What that mean? F means the position of x. You put what? You put 0. So this can be 3 times 0 over 2 times 0 and then minus 3. So this is going to be equal to 0 over 0 minus 3 equal to negative 3. So f of 0 equal to negative 3. Negative 3. So now we go to the option. Equal to negative 3. And our option, multiple choice. So I'm saying it seems to be f of 0 equal to, man, what am I doing here? Man, it's not negative 3. What you doing? 0 equal to 0. And then 0 minus negative 3 equal to negative 3. But a 0 divided by anything equal to 0. Guys, please don't confuse the previous one, right? This is 0 divided by anything equal to 0. But if you have a 0 at the denominator at the bottom, it's when you say undefined. Now we go for the second one, B. For the B, okay, note guy, man. This is very important notes. I'm going to have to use the red pen. Probably you can remember note, big note. I'm going to put, let me draw a picture, man. I use it like cartoon. No. Okay, so this is Bantu. So I'm gonna say hey, and then I'm gonna do like, you see, like Spider-Man here, like hey, please remember hey, and then this is like my Spider-Man outfit, and this is gonna be like, oh, my Spider-Man blue one, and then I'm gonna dress and I'm gonna jump. See, I'll tell you everybody like, hey, listen, this is very important notes. Hey, okay, listen, this is very important notes. If you're given x squared equal to 4, meaning when you square it throughout, you say this is this concept, so x equal to plus or minus 2. Remember that. If you given both sides, you must say plus or minus 2. But if you have only square root of 4, the answer must be only 2, not plus or minus. This is very important, guys. Make sure you put in your mind. Keep in your mind. So if somebody give you, now let's say y squared equal to 16. So what you're going to do, you're going to say square root. So y, this and this cancel, so y equal to plus minus what? 4. But if they give you only separate, let's say 16, what is the answer? The answer must be only 4. So remember, that's very important. So let's go to the question here, right? So question 2, they say you have to find, excuse me, you have to find all g of 6. So we go g of 6. So it's g of 6. So we have a g of x. Our g of x. Our g of x is known, which is g of x equal to 2x. Okay, so you say you given 2 over, let me put line here to separate, 2 over square root of x minus 2. So x minus 2, man, x minus 2. So now we say, okay, so what do they want? G of 6. So g of 6, so we're going to say g of 6, so g of 6 equal means whenever there's an x, I'm going to put 6. So we're going to have a 2, just a 2, the way how it is. And this is going to be 6 minus 2 because we plug in the value of x here. So we get 2 and then square root of 4. So guys, you tell me, if you square root 4, what you're going to get? Plus or minus 4, only 4. I give you 1 second to think. Give me the answer. Give me the answer. 1, 2, 3. Plus or minus 2. No, you're wrong. Not plus or minus 2. It's just 2. So the answer is going to be 2. And here it's going to be 2. You know why? Because you don't have a x squared equal to square root of 4. Or y squared or a squared equal to square. You just say square root of 4. So it's going to be only positive. It means positive. So 2 over 2 equal to 1. So g of 6 equal to positive 1. So I'm saying, but here in the option, they give you plus or minus 1. So that's not true. That's not true. So B is false, but A is true. So A was true. The A was true. The A was true. This one was true. But the B was false. You see how they confuse it there, right? And they give exactly the same thing because the latter student they will have say plus or minus. So B is false. Now we go for C. So for C, they say get G of X, given G of X times square root of H of X. They say if you simplify this, it must be equal to 2. Now we go, what is a G of X? We have a G of X, we have a G of H of X. Our G of X is given here. Shows me what is the G of X? We have it here, man. Okay, it's 2, so we say it's 2. Square root of X minus 2. But we're going to have to multiply, multiply H of X. What is the H of X? H of X is that one right there. X minus 2. And the bracket, they multiply by X minus 3 over X minus 3. So what I'm going to do here, face of 4, man. So I'll say, okay, they say they want us to prove this if it's true. Excuse me, if this is true. So I think it's more professional or more appropriate if I say take left hand side. Take left hand side of this. And you have to simplify, and then finally it has to give us 2. Let's see now. So this and this is the same thing, so cancel. So we're going to be left with 2 and then X 2 and then multiply by square root of X minus 2. You know what I'm saying? X minus 2. So now you have a, see what I'm saying? Let me write good, man. This handwriting very bad. My grade 4 teacher, remember, she used to be, she told me, man, when you write your stuff, you have to write well. So I'm going to have to rewrite well. Just like I when I was grade 4. So we say 2, and they have what? I'm going to rewrite well over X minus 2, and then multiply. I'm going to rewrite right so I don't make mistake. X minus 2, and then we multiply by X minus 2, and then we have what? X minus 3, my apology, and then X minus 3. So you see, this is a similar thing. X minus 3, X minus 3. So we left with 2, X minus 2 times, and then square root of what we left with, which is X minus 2. So you see, this one has no friends, so it's like over 1. So this and this cancel. So the answer equal to 2. So the answer equal to 2. So let's go to the option. Yeah, it's true. So since left hand side equal to right hand side, then it's true. True. So we have seen, excuse me, A is true, B is not true, and C is true. So A and C. So man, there's a lot of A and C here. A and C. So let's go to the options. So A and C, we go to the option. C is option 4. So A and C is option 4. Option 4, option 4, option 4, option 4. Question 7, option 4. So question 7, option 4. So option 4 here. Option 4, question 7. And so long as 100%. You know what I'm saying?